When we have angles on the coordinate plane, where the terminal side, and we got angles in standard position, and the terminal side lies on the x or y axis, we have what are called quadrantal angles. And they're either going to be 0 degrees or 90 degrees or 180 degrees or 270 degrees or 360 degrees. And if they're in radians, well, it would be if it's on the positive side, if the terminal side is on the positive side of the x-axis in radians, that's either going to be 0 radians, or if it comes all the way around, that's 2 pi. At the 90 degree position in radians, that's pi over 2. And the negative side of the x-axis, that's 180 degrees or pi radians. And if it's on the negative side of the terminal side is on the negative y-axis, then that's 270 degrees or 3 pi over 2 radians. Now notice something else here. Our r value, as we looked at before, takes on either the x or the value of the x or y axis, or it could be the negative of the x value. So see right here, when we're on the positive side of the x-axis, our coordinate is not just x and y, it is r and 0. And when we're here on the positive side of the y-axis, notice that our coordinate is x is 0 and y is r. And when we're on the negative side of the x-axis, in this position, notice that our x-coordinate is negative r. And that's actually going to make that r a positive. I'll show you why in a moment when we look at a specific example. And when it's on the negative side of the y-axis, we got a 0 and a negative r. These are quadrantal angles. It's multiples of 90 degrees or pi over 2 radians. So let's look at a specific example. So here we're told we got the terminal side of theta in standard position contains the point negative 2, 0. Find the values of the 6 trig functions. Well, what this is really saying is then, so negative 2, 0 is going to be out here. Now, if I were to take that Pythagorean theorem to find the value of r, let's just plug that in because we've already discovered that r equals the square root of x squared plus y squared. So here we'd have negative 2 squared plus 0 squared. Well, of course, that's just the square root of 4. Negative 2 squared is 4. 0 squared is 0. And therefore, r would equal 2. Now, so that being the case, let's go through our sine functions. So we would have the sine of theta is y over r. Well, that's going to be 0 over 2, so that is 0. The cosine of theta is x over r, and x is negative 2 over 2, or negative 1. Our tangent is y over x. Well, y is 0 over negative 2. Our cosecant Our cosecant is r over y, or the reciprocal of this, but let's see, if r is 2 and y is 0, well then this is undefined. Let's see, the secant is equal to r over x. Well, r we said is 2 and x is negative 2, so this is negative 1. Cosine and the secant both are negative 1. And the cotangent is equal to what did I put here for the tangent? I didn't finish that, did I? That's 0 over negative 2, which was 0. And so the cotangent then is x over y, or negative 2 over 0, but then we can't divide by 0, so it is undefined. Now, shortcut is if I take the r, I just take the value of whichever is the coordinate that's the non-zero coordinate, and whether it's negative or positive, it becomes positive for r, if you notice. But it's probably easier just to plug it in, put the x coordinate and the y coordinate, take the square root of it, and again, to let that be your value of r, rather than trying to remember where does r become positive or negative, because this will do it for you. All right, quadrantal angles, excuse me.